We're now moving on to reaction types. The first type of reaction I'm going to talk about is synthesis. But before we get there, let me bring in the states of matter. I'm going to talk about these again. Solid is S, also represented by C. You may see that in Chang. L is liquid, G is gas. Aqueous means dissolved in water, is represented by AQ. We will be using those. So synthesis is also called a combination reaction. The generic form is A plus X yields AX. So I have two elements that are going to basically come together and form a compound. So in this situation, first I have sodium. Sodium's in group 1 is a plus 1. Chlorine's in column 17 minus 1. They come together in a 1-to-1 ratio. Sodium is black, it's a solid. Chlorine is red, it's a gas. And I form sodium chloride, which is a solid. And you won't have to worry about that. But I'm just putting them there just so you can recognize them. And then we balance it, and it would be fine. 2, 1, 2. Calcium, next one, calcium's in group 2 plus 2. Oxygen's in group 16 minus 2, 1-to-1 ratio. And then we balance it. Lithium plus 1, sulfur negative 2, 2 lithiums are zeroed out. Then we balance it. Aluminum and oxygen. Aluminum's in column 13 plus 3, oxygen's in column 16 minus 2, crisscross method, Al2O3. And then we balance it. Now, this is important. You're going to see this on the test, everybody. You're going to see this. You better be able to balance stuff. You better be able to know your nomenclature. Now, there's another way. I can actually break this down a little further. So I threw in this slide as well. It's still a combination, but what you could have done. Remember Hopwrinkle, by the way. So my sodium's my chlorine, I remember Hopwrinkle, I recognize it that way, and then I break it down to their charges, I bring them together, and that's how I get the compound. Calcium and oxygen. Oxygen is diatomic. Again, calcium's a 2 plus, oxygen's minus 2, that's where I form calcium oxide. And I balance it. Lithium, sulfur, both stand alone. Lithium's a plus 1, sulfur's minus 2. The 2 lithiums are zeroed out. That's how I got the product. Then I balance it. Aluminum, oxygen is diatomic. Oxygen is 3 plus, aluminum is negative 2. Crisscross, that's how I form a product. So you can actually take it to this extent if you need to. It is the exact same thing we just did. Another form of synthesis, another example of this one, is unique because there's actually two products. Synthesis, and the first one was actually easy to recognize because there's just two individual elements. The only thing they do is come together and form a compound. Well, here I have two compounds, and you don't want to confuse it with double displacement, which we're going to get to. Right now, once you recognize a metal oxide and water's present. So in this situation, leave your water alone. In this reaction, it's unique. You're just focusing on the actual metal. The metal was going to leave the oxide, which is a 2 minus, and join up with the hydroxide, which is OH minus. And so all I have to know to form my product is to know the charge of my metal. Well, sodium's a plus 1, so it comes together with hydroxide with the 1-to-1 ratio. And then I balance it. Next one, calcium oxide plus water. So the calcium is going to join up with the calcium hydroxide. I need 2 hydroxides to zero it out. Therefore, I use parentheses. In this situation, it is already balanced. Look at my next one, aluminum with 3 plus. It's going to form with hydroxide. So I need 3 hydroxides to protect it with parentheses. And then I actually balance it.